All right. So, moving on to problem number 7. This is our first proof here that we have to fill things out on both sides. If you need to check in on a definition or anything like that, flip back to the front page. It's all there. Oh, by the way, I need to make sure everybody's aware of this. Everybody listening? Everybody listening?
Okay.
Yeah, thank you, Rob. This is a very short unit that we are currently in. Meaning like these are the last notes for this entire unit, which means we got another test coming up soon. Your proofs test is going to be on Tuesday. Yes. What's that? We'll have time. We'll have a lot of time to do that. We're going to finish the notes from yesterday, and then you'll have the rest of the class to work on the assignment. So Monday, I'm going to get you the unit review. It's pretty short. Tuesday will be the unit test. It's pretty short because this unit was pretty short. Yeah. A pencil? Yeah, come on up. Yeah, if anybody ever needs a pencil, feel free to just walk behind here and grab one from the big pencil box. There's tons of pencils there. All right. So let's see, problem number 7. And what I think I'm going to do today is I'm going to call on some folks randomly to help me out. So be prepared. That's not random though. Hang on. Yeah, basically, if you get step 1, statement 1, or reason 1, you get lucky because it's always the same thing. And I'm actually going to go ahead and take attendance real quick as well. So if you haven't gotten your stuff out, get your stuff out. All right. Let's see who's here and who's not. We definitely have a couple gone today for sure. So we got our Alexis here, Adele. No. Rob's here. Jackie, no? Here? Nancy's here, Savannah's here, Serenity's here, Catherine's here, he is here, Matthias is here, we got Seth, London, Aaron, Valeria, Astra, Jack. No. Ebony, Angel's back, Daisy's here, Eden's here, Ivan's here, Madison's here. Lotus, Aiden, Mabel, Louis. No. Adrian. No. No, I tested a bunch this week. I got a lot of at-home tests. Okay. 1, 2, 3, 4, 5. All right. All right. Cool. Here we go. So, statement number 1 says that angle 1 is congruent to angle 4, and I'm just going to go ahead and get some random numbers generated here on the calculator. Everybody's got a number next to their name on my rule sheet. So this is going to be Louis, who's not here. All right. Caitlin, what's the reason for number 1? Given. Yeah. Always lucky if you get the first one, right? Yeah. Okay. Statement number 2 has a reason of the definition of congruence. So I'm going to give this to Roth. Yeah, this is your number 3.
Yeah.
So yes, make sure to put the lowercase m though. Yep. Measure of angle 1 equals measure of angle 4. Good. That is the definition of congruence. Remember, this works both ways. So if we started with the m equals and then went to the congruent, that would be the same reason. All right, here's another easy one. This one is going to, Adrian's not here. This one is going to Angel. Statement number 3 has a reason of given. So what else is in the given that we haven't used? What else is in the given though that we haven't used up at the top? So you used angle 1 is congruent to angle 4 in the given. What haven't we used from it? Yeah, angle 4 and angle 5 form, I'm just going to say LIN and then PR for pair. So linear pair. That's given. All right. Next, angle 4 and angle 5 are supplementary. That is going to be Matthias. So if two angles form a linear pair, then they are supplementary. Which one is that? That is the supplement theorem. Yeah, you got it. So number 4 is the supplement theorem. And if you're wondering about that, if you look at statement 3 and statement 4, angle 4 and angle 5 form a linear pair, which means that angle 4 and angle 5 are supplementary. If you go to the front, where all that information was yesterday, if you go down to the supplement theorem, if two angles, angle 4 and angle 5, form a linear pair, then they, angle 4 and angle 5, are supplementary. So that's what we just did right there. The supplement theorem. All right, next one says a reason of definition of supplementary angles. So let's see, Adele's not here. How about Aiden? What is our statement going to be for number 5 if we use the definition of supplementary angles from this to this? So if you look at the definition of supplementary angles on the front, that is right here. So if they're supplementary, then what's that? The sum is 180. Okay, so how would we write that with those two angles there? And you can also check maybe a previous proof that we did. Oh, here we go. Step 4 to step 5 on this proof number 2 says the supplement theorem for 4 and then definition of supplementary angles for 5. So we're gonna write that, but with the angles that we have right here. So what's 5 going to be? There you go. Measure of angle 4 plus the measure of angle 5 equals 180. Nice. Okay, number 6 has a reason of substitution. And I would like to hear from Mabel. What would the statement be? Would you like a hint? Yeah, okay. So let's look at what we have right here. So we know that the definition of supplementary angles works from here to here, but it also works from here to here. And this last one says that angle 1 and angle 5 are supplementary. So as opposed to having measures angle 4 and angle 5 add to 180, maybe we should use, instead of angle 4, angle 1. Yeah. So it's going to be the same statement as we had here. We're replacing angle 4 with angle 1 because angle 1 is equal to angle 4. So that would be the substitution steps. We're going to start measure of angle 1 plus the measure of angle 5 equals 180 by substitution. And then reason number 7. Seth? If angles add up to 180, that means they're supplementary. It's the same thing as if they're supplementary, they add up to 180. So which one's that? There you go. Definition of supplementary angles. So definition of supplementary angles works both ways. If they're supplementary, they add up to 180, or if they add up to 180, they're supplementary. Both would be the definition of supplementary angles. All right, number 8. Let's go on from there. Are there any questions on number 7 though? We got 2 more to go after this. Any questions? Of supplementary angles? Because if you go from supplementary to adding up to 180, that is the definition of supplementary angles, and it works the other way as well. So if you go from 180, 2 angles adding up to 180 to the same 2 angles being supplementary, that's the same reason. Because definition of supplementary angles works forward and backwards. All right. Number 8. Reason number 1 is going to go to Mabel. Gavin, yeah. Same numbers might show up more than once. Next, let's hear from Serenity. The supplement theorem. So go to the front. Go to the front page of these notes. Find the supplement theorem because that's what we're using here. And which part of the supplement theorem do we have right now, Serenity? Do we have the linear pair or do we have supplementary right now? In terms of the statement. So what does it say right here? It says they form, right? They form a linear pair. What is the result of the supplement theorem? Yeah, it means the angles are supplementary. So if these 2 angles form a linear pair, that means that those 2 angles are supplementary. How would we write that? What 2 angles do we have? Angle 1 and angle 2 are supplementary. That's our statement. The next one, statement number 3, is going to be pretty easy as well. Not here today. Let's go to, not here today. Let's go to Aaron. There you go. That was the other part of the given that we hadn't yet used, and now we've used it. All right, so the next one is the reason is the definition of supplementary angles. So if angles add up to 180 degrees, then what, Savannah? What is the conclusion of this if we're using the definition of supplementary angles? So we have that here. So what's the other end of that then? So if the sum is 180, let's see. Right here, sum is 180, which means that the 2 angles are. Yeah. So just use the 2 angles. And we're going to say angle 2 and angle 3 are supplementary. Here's something interesting. I'm going to point something out to you real quick. Statement number 2 and statement number 4 are very similar. They both say that pairs of angles are supplementary. However, the reasons for those things are different because the statements before each of them are different as well. So if 2 angles form a linear pair, then they are supplementary. That's the supplement theorem. If angles add up to 180, then they are supplementary. Same conclusion, but we're using a different thing. We're using a different reason. This is the definition of supplementary angles. So even though we're basically making the same statement with 2 and 4 with different angles, the statements before them require us to use a different reason to make those statements. All right, then, are there volunteers for this last one? Vicky hasn't answered yet. Substitution? No, I think that's all right. So what are we substituting? Oh, wait, hold up. No, it's not. It's not. Okay, so here's the thing. If it was the definition of congruent, we'll get there. If it was the definition of congruent, the previous statement would have been measure of angle 1 equals measure of angle 3. I heard it over here. I think it was what Matthias said. It's the congruent supplement theorem. Yeah. We're going to say that, Nancy? Congruent supplements theorem. Here's why. If, let me get my highlighters. This one congruent supplements theorem is very similar to the transitive property. So it says angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are also supplementary. So angle 1 and angle 3 are both supplementary to what angle? Angle 1 and angle 3 are both supplementary to angle 2. So both angle 1 and angle 3 are supplementary to the same angle, which means they are congruent to each other. That is what the congruent supplements theorem says. If angle A is supplementary to angle B and angle C is supplementary to angle B, so if you have two different angles supplementary to the same angle, then those two angles are congruent to each other. That's what we're saying here, and that's what was used right here. All right, it's kind of like the transitive property, but it's not the transitive property because it's not three things all being congruent. It's two things supplementary to the same thing. Therefore, those two things are congruent to one another. Kind of a tough one. All right, last one, number 9. Here we go. Who gets the easy one? I don't think that person's here today. How about Daisy? Given. All right, given. So we have given for reason number 1. Reason number 2, angle ABC is a right angle. This is going to Evelyn. Reason number 2, proof number 9. So Evelyn, can I ask you a quick question? What is this symbol right here in the middle? What's that? So the upside down capital T right there, that's perpendicular. So do you see anything on the first page with all of our definitions and theorems and stuff? Do you see anything there that uses perpendicular? On the very first page? Catherine, you want to help out? So let's see, the complement theorem. Hang on. The complement theorem does use the word right angle, but the complement theorem is talking about two different angles as opposed to a single angle, but it does use right angle, but it also uses complementary. Where do you see, let me ask you this, where do you see either a definition of theorem or a postulate that uses both perpendicular and right angle? Which one uses perpendicular and right angle? Serenity? Yeah. So that's going to be our definition of perpendicular. If you have perpendicular lines, then it creates a right angle. So therefore, if segment AB is perpendicular to segment BC, then you're going to get a right angle. At least one, usually 2, sometimes 4, if the things actually intersect. The next one says, we have a reason of a definition of a right angle. So go look at the definition of a right angle. And then I want somebody to tell me, let's see, not somebody, I want Lotus to tell me what is our statement. What does the definition of right angle say? A right angle equals 90 degrees. Okay. So if a right angle is 90 degrees and angle ABC is a right angle, what do we know about angle ABC? 90 degrees. Yeah. So we're going to say the measure of angle ABC equals 90. That is our definition of a right angle. We're using the angle that was a right angle, and we're making a statement about that same angle adding up to equal, or not adding, but being 90 degrees. We will maybe make that statement, but it's not there yet. How about number C? I just answered. Okay, let's go to London. How about reason number 4? Reason number 4. Look at the diagram real quick. So you look at the diagram, angle 1 right here plus angle 3 right here adds together to equal angle ABC. So what do we have on our first page that talks about two angles adding up to equal a larger angle? There you go. Angle addition postulate. All right. Next. Angle 1 plus angle 3 adds together to equal this whole top angle here, which is angle ABC. So part plus part equals whole. All right. Now,
definition of the triangle.
That's what I said. No. It's not.
what do we think about this one? Is it given? Doesn't quite look like it's given. For number 7, the reason is given. So we'll use the other part of the given on number 7. But right now, I think we're getting closer.
Yeah.
The complement theorem? Okay. Move on a little bit further. We got a lot of different answers here, huh? Morning. Lots of different answers. Okay. I'm gonna just hang on here real quick. Okay. We are on number 9. So, Vicky, what'd you say a second ago? Transitive. Yep. So this one is transitive, because here's the thing, there's nothing previously that would allow us to say that angle 1 and angle 3 add up to 90 in terms of like a definition of anything. But what we can say, we can reason through this, because if this entire angle up here, ABC, if it equals 90 degrees, which we have here, and if those two angles add together to equal this larger angle, then those two angles would have to also add together to equal 90. So transitive property says, if you have a first thing and it ends up equaling a third thing, then both of those things must equal a second thing in between them. So here's the third thing again. Here's our 90. Here's our first thing again right here, measure of angle 1 plus measure of angle 3. And then the thing that both of those things are equal to is the measure of angle ABC. There it is. So if the first thing here is equal to the second thing over here, and the second thing over here is equal to the third thing here, then the first thing is equal to the third thing. So that is the transitive property. All right. Let's see. Number 6. The reason is the definition of complementary angles. So Madison, the reason is the definition of complementary angles. So go look at the definition of complementary angles real quick. What's that? It means the angles add up to 90, right? We already have that part of it though. It's right here. So what's the other side of it say? It says what? But we have that here. So what does the other side say? So right here, it says the sum is 90, right? But what is this? Yeah, it means they're complementary. So we're gonna say angle one and angle 3 are complementary. So because we already had the part of it that said they're equal to 90, we're going to use the part on the left that says they're complementary. So if angle 1 plus angle 3 equals 90, then angle 1 and angle 3 are complementary. Statement number 7 is going to be another easy one because of the reason. So let's see, Evelyn, your number came up again. Reason number 7 is given. So that means there's something else from the given information at the top that we haven't used yet. Good. Angle 2 and angle 3 are complementary. All right. Now I'm going to give you all a hint. You ready? I'll give you all a hint here. Look at reason number 5 from the previous proof. It is not going to be that exact one. However, it's going to be very similar to that last reason from the previous proof. Let's see, Jack's not here. So let's go to Camden. The congruent complements theorem. Yes, this is the congruent complements theorem. And that is because if you look at the previous two statements, angle 1 is complementary to angle 3. Angle 2 is complementary to angle 3. So angles 1 and 2 are both complementary to the same angle. Therefore, they are congruent to each other. That is the congruent complements theorem. Kind of like on the last step of the previous proof, we used the congruent supplements theorem. We're doing it this time, but with complementary angles instead of supplementary angles. All right. That's all I got for you.